At the end of this video, solving quadratic equation using completing the square method should not be difficult. Let's get started. What are perfect square? Perfect squares are numbers that can be square rooted, and we have four. We have four. We have 9. We have 16, 25, 36, 64, 81, 100, 121. So these are perfect squares, and they can be square rooted. They can be written as an index form of power 2, 2 raised to power 2, 3 to power 2, 4 to power 2, 5 to power 2, 6 to power 2, 8 to power 2, 9 to power 2. Of course, we have 49, that's for 7, 7 to power 2. So every digit value expression that can be written as a power of 2 are perfect squares. Not all numbers can be written as a perfect square. If we have a number like 17 cannot be, 20 cannot be written as, something raised to power 2, except we'll have it in, you know, short form, whereby we have 20 equals to uh, 2 times 10, then we break it down to 2 times 2 times 5, then we have something like this. So, this form. So this is not a perfect square. So let's look at how this relates to quadratic equation. Okay, so let's consider a particular equation like x squared plus 8x plus 16. This expression, okay, we can write it as an equation. To make it an equation, we put equals to 0. If we solve this equation using factorization method, let's see what it gives us. We have x plus, so what are we going to add together to give 8? That's 4 and 4, that's 4x plus 4x plus 16 equals to 0. So we have, we factorize x and 4x, we group them into 2 and we factorize, the group of 2's. So we have x and 4x to be, x is common, then we have, we're left with, oh, this is square, then we have x here plus 4, we close the bracket, 4x and 16, we have positive 4 to be common, then we have x plus 4 equals to 0. So then let's bring out the common factors. X plus 4, x plus 4 is common. So we bring it out, x plus 4 is common. Then what is left? We have x plus 4 equals to 0. Then we bring the two together. We have x plus 4. Since they are same and they are similar, so we can write it, and they are the same, so we can write it as square. That is, these 2 raised to power 2 equals to 0. So therefore, this equation that gives us, x plus 4 raised to power 2 is a perfect square quadratic equation. So not all quadratic equations are perfect square. So, but we can come to conclusion in this video which equation will be a perfect square. So we will be able to identify by sight, not by solution or by applying factorization method, but by observing a particular equation or an expression, we will be able to say if it is a perfect square or not. Okay, so let's erase this. Okay, how we can equally slide it up. We can slide it up. Okay, let's just write it. Let's write the result here. We have x plus 4 all square equals to 0. So um this expression gave us this result in part 2, making this a perfect square. But how can we always have a result like this in this form? Now let's use a general form for it, like the notation of letter, and by algebra let's apply some principles of mathematics to it. Okay, let's see. Having x square, which is always you know um the most common unknown for quadratic equation. So plus, so now we're not going to use a number, so we're going to use an unknown. So let's use m x. You have to have another x here, so it can be a balanced quadratic expression or equation. So we have x squared plus mx plus, okay, let's put a letter here as well. So let's put k equals to. So how can we have an expression like this that will give us something like open bracket x plus a close it raised to power 2, that will give us a result like this? you know this is where it all starts from, and we are going to notice something, that there is a relation between the the left hand side and the right hand side. So let's look at this. Let's open this bracket quickly. So now equating the two sides together, x square are common, so you can write it out. X square is still the same as x square. Then we have mx is still the same as 2ax. Then we have k is the same as a square. Now we know that, okay, fine. The first side is balanced. Now let's balance the second side. So at the second side we have mx equals to 2ax. This side now. So now we realize that m can cancel out m. So we are left with m equals to 2a. So what is a from here? A is let's divide by 2. 2 cancel 2. So a is equals to m over 2. Let's take note. This is the first equation. Say 1. Now let's look at the last part, that is k to a square. So it says k, the identity between k and the other side is a square. Now we can recall and say, since a is m over 2, then a square is m over 2 all square. That is this a, this is its m over 2. So this is the relation that binds the two sides. So let's call this equation 2. Now what can we say about this whole thing, starting from here? Now we can say that k is m over 2 all squared. That is, to get every value of k, of this k, that makes this expression a perfect square, we need to divide this m that is here. Whatever value here, we divide it by 2 and we square it based on the final solution that we derived from the general form. So we got k is m over 2 all square. Okay, can we try it for the first question we did? Okay, we had x squared plus 8x plus 16 equals to 0. This 8 here is our m, and then 16 is our k. So let's try it. It says k is always m over 2 all squared. Then let's check if this relationship is true. So k equals to our m is 8. Let's divide it by 2 like we have here, and let's square it. So we have k equals to 2 in 8 is 4. We have 4 raised to power 2. K is 16. That means k is correct with this. So that means this is true. So for every value, for every kind of quadratic equation we are given, that means we can place our attention on what the constant is, what the k part is. So let us assume an expression x squared plus 6x plus what will make this a perfect square. That means for me to get what will make this a perfect square, I will need to pick out this divided by 2 and square it. I have to do 6 over 2 all square. Then we have 2 in 6 is 3. 3 raised to power 2 is 9. Therefore, I need to add 9 to this. Now let's check it if it is a perfect square by factorizing. We know this is 6, this is 9. So we look for what we add together to give 6, and what we multiply together to give 9, of course, is 3. In fact, having a result like this should tell you that it is a perfect square, because we're going to have something like x squared plus 3x plus 3x plus 9. Then we have x squared. Oh, we need to factorize. So x is common. X plus 3. Oh, coming. What is common between positive 3x and positive 9? So it's positive 3. We close it. So we're left with x here plus 3. So we have x plus 3, x plus 3, which is x plus 3 raised to power 2. So it is a perfect square. We have something like this. And if we can pick out the final answer, we can pick the value of k from here, from this particular value, then we should be able to have a very short way of writing this instead of using factorization method. So let's just look at how we can deal with that. Okay, over here there's a relation like k is equals to a square. Okay, let's look at another one. There is an equation here that says a is always m over 2. This same m is always at the side based on the solution that I give in this video. M is 6. So that means if we divide 6 by 2, we should have a. Okay, let's check it. Equals to, we have x plus what? A, we pick the value of m here, which is 6. 6 over 2, as 6 over 2, then whole square. And we have x plus 3 all squared. So we have an answer that is the same with what we had here. So this is the same with this. That shows they're correct. So let's pick another expression. X plus 7x. So what are we going to add to this to give a perfect square quadratic equation? And what will be the answer? So now we know that we need k. K is always m over 2 square. That is whatever you have here, you divide it by 2 and you square it. So you should have something like 7 over 2 all square. So you can simplify it and have a value for it, but it's going to give a fraction. So then let's check what will the final result be. The final result should be x plus, what will be a is always m over 2. So we have 7 over 2, then all closed. So this is the value for this expression. So you can try it out and check if it's correct. You can open this bracket to check it. We have x plus 7 over 2 all raised to power 2. Let's try to open this bracket. We have x plus 7 over 2, x plus 7 over 2. So this should give x times x, x squared, x times 7 over 2. We have plus 7 over 2 x. We are done with x. Now let's move to plus 7 over 2. Plus 7 over 2 times x is plus 7 over 2 x. Then this times this will give plus 7 over 2, 2 times. We have 7 over 2 to multiply 7 over 2. That's plus 7 over 2 square. So we have x square plus this and this are the same. So what is 7 over 2 plus 7 over 2? So we have, or we can write it as 7x over 2 plus 7x over 2 is still the same. So we can write it in the way, we will understand the process. X square plus, then the LCM is 2, 7x plus 7x plus 7 over 2 all squared. Then we have 7x squared plus 14x over 2 plus 7 over 2 square. So from here we know 2 can divide 14, which will give 7. So finally we have x squared plus 7x plus 7 over 2. Then we square this, so which is actually the same. Let's sum it out. I'll make it smaller so we can see. Okay, we have this to be the same with this. So we are good to go. Thank you for watching this video.